One of the most basic things that we might do in the empirical study of gender issues, for example, is ask whether female-headed households have different behaviors from male-headed households. So we might assume there's some mechanism that operates for that to be the case, some gendered mechanism. So we have some outcome variable that we're interested in. For example, say the percentage of household income that's allocated to luxury expenditures, or the percentage of household income that's allocated to food expenditures, and we calculate the mean of that percentage for all of the female-headed households, and we calculate the mean of that percentage for all of the male-headed households. And then we compare the mean of the male-headed households to the mean of the female-headed households. If the mean of the male-headed households was 78%, that is 78% of their income was spent on luxury products, and for the female-headed households it would be 22%, then we wouldn't have to do much more. Those differences would be very large, and we would think that they speak for themselves. But if the differences are closer, so if the male's percentage of spending on luxury goods was 52% and the female's percentage spending on luxury goods was 49%, then we might be worried that maybe the difference in the two means was spurious. So our statistical significance of those differences in means will depend on the variation in the data and the sample size that we have. With a much larger sample, we can be more confident that the difference in means that we found is statistically significant. And if the samples have a lot of variation, again, we can be more confident that the means are statistically significant. So we'll calculate a t-test for the difference in the means, which is the difference in the sample averages, the male minus the female, divided by the square root of each subsample's variance estimated from the sample that we have, divided by the number of observations in the sample added together. So you have the formula there with you, so you can check that out. So what you might want to be doing is calculating two means for two samples, two variances for two samples, two sizes, how many observations there are for each sample, and then plugging those into the formula for the t-statistic, and then asking whether the resulting outcome for the t-statistic is greater than 2, which is our usual rule of thumb, 1.96 for a 5%, 95% confidence interval that the means are indeed different. So that's a basic way of calculating a difference in means, standard tool that we'll always use whenever you see two means being compared of anything. The means of women on SAT scores compared with the means of men on SAT scores. The means of heights of women compared with the means heights of men. You'll always want to be comparing using the t-test of the difference in means to see whether the differences are statistically significant.